to our wonderful technical difficulties. We're back.
Yes, and we're glad to be back.
Yes. We're going to review AM and FM waves because I had to delete those slides from the last recording.
So hopefully we will talk about amplitude modulation. Modulation basically means that it is something that is changing to a degree.
Think about it as the word modified. It's being tweaked, altered, changed. It's not the same, and it will not be uniform.
Talk about AM and FM. The A is going to stand for amplitude, and if that word's familiar to you, it's because we just learned it on the mechanical waves. For amplitude, and frequency was another one of our vocabulary words.
So in case you've forgotten what that word amplitude means, it is the distance from the resting position or midpoint of a wave to the farthest that wave travels from it. It is going to be from the resting point to crest or from the resting point to the trough. And if you have forgotten frequency, that is going to be how many full wavelengths travel past a given point in a specific amount of time.
Okay, so we have amplitude modulation and frequency modulation, meaning the amplitude changes on AM and the frequency changes on FM.
And here you see that distance on AM from the midpoint is going to fluctuate and change. And on FM, the amplitude will stay the same, but how many waves would pass in a given point at any time is going to change.
Yes. And most of the time when I draw waves, they look like AM. I'm not as symmetrical as I need to be. But notice on the frequency, all of those have the same height, the same crest, and the same trough. So keep that in mind as you go.
The name is literally going to tell you what changes. In amplitude modulation, the amplitude will be modified or changed. In frequency modulation, it will be modified or changed. In amplitude modulation, since the amplitude is changing, the frequency will stay the same. And in frequency modulation, since the frequency is changing, the amplitude will be what stays the same.
One other thing you need to know is when we draw our electromagnetic spectrum, we always have radio on the low frequency side. For AM and FM, AM is lower than FM. So if you were drawing the sub context of radio, you would put AM on the left, FM on the right. So that tells us that the AM has a longer wavelength, lower frequency, lower energy. FM has the
higher energy and is going to have higher frequencies. And this is what's actually going to allow it to pass through our ionosphere, which is part of our atmosphere, is because it has that higher energy and is capable of escaping.
FM stations come in very, very clear. However, if you get very far away, you can't pick them up anymore. That's because they have poked through our ionosphere.
They've escaped, essentially.
Yes. Whereas the lower energy AM, they reflect or bounce the ionosphere, and they can travel further distances. Since they have lower energy, they aren't as clear. Your parents or grandparents can probably talk to you about listening to the AM stations years ago. You can hear radio stations in Chicago or Los Angeles or New York. That's because these waves will travel a long distance, but they don't come in very clear.
And unlike your FM waves, or if you've been on a road trip, I remember road trips.
Yes.
I remember vacations. But you drive out of range or signal of your favorite station, you have to go and search for the newest one that you like, that you are within signal range of. So sorry about that getting cut out and our little technical difficulties that keep happening, but we still love you guys. We wish you were here, and we miss you.
Yes, we do. Bye-bye.
Again.